All right, for this next set, there is a typo. It says state why it should say triangles are congruent. And then make a congruent statement for the triangles. Remember, order does matter. So we're going to look at these and we're going to try to determine if these different sets of triangles are congruent. So we're going to just do a quick review. How do we prove triangles are congruent? So proving triangles are congruent. We have a few different ways. We can use side, 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 which means each side of one triangle is congruent to the corresponding side of the other. Side angle side means two sides of one triangle are congruent to two sides of the other, and then the included angle, or the one between those two sides, are congruent. We have angle side angle, which is similar, but two angles are congruent, and then the included side. We have angle angle side, also known as side angle angle. What this is, two angles are congruent and then a non-included side, so not the one in between them. And then we have the HL theorem. This only works for right triangles, and this is the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of another. So let's go ahead and look at number 7. We have two angles are congruent, and then we notice that these two triangles share a side. So whenever they share a side, that side is congruent to itself using the reflexive property. And so we can say these are congruent by angle, angle, side compared to angle, angle, side. So this is an angle, angle, side. And I'm going to go ahead and put the congruent statement down here. Triangle, and I'll just start with this one on the left, ABD, is congruent to triangle. And we want to put what corresponds to A, so that's C. And then when we come into B, D. So that's the congruent statement, and order does matter. Number 8, we have two sides congruent to two sides there. We also have vertical angles here, so these are congruent. So we know that this is congruent by side, angle, side, compared to, and we're going to start with this because of the double arc, side, angle, side. So we can put a side, angle, side here, and we can write a congruent statement. Let's go alphabetical order. We'll do E, F, G, congruent to triangle. So we have to be careful. Here we started with E. E is connected to this line with one point, or one little mark on it. Let's get rid of our circling. And so E corresponds to I. And then we went EF, so we need to go I up to H. So I, H, and then down to G. And that's our congruent statement for that one. Number 9, we have congruent segments here, the top and the bottom segment. We also have that those lines are parallel. And then these things do share a side. So I'm going to go ahead and mark this. This is congruent to itself. So we have two sides congruent. And then if we think we have these parallel lines cut by this transversal, we have alternate interior angles here. And so by marking that, we see we have again side, angle, side. And then triangle, let's just go JKM. So JKM, that's going to correspond to LM. Okay. And our last one here, this one's kind of set up funny. This is again side, angle, side. So we can prove it's congruent. And because it's marked definitely side, angle, side. Let's start with this top triangle, NOR is congruent to. Now NO, that's connected to the two marks, and so we need to connect to the two marks. So that would be P comes first, P. Then we went NO, so PQ, and then down to R. Now for all of these, the statements I made are not the only ones because we can put them in a different order. So I'm going to look at this last one just to show you. N corresponds to P, O with Q, and R goes with R. So we can put the first in any order, like we could have put O and R. And as long as O, here O corresponds to Q, so I'm going to start with Q here. Then we went to N, N goes with P, and then R. So that's another way to write it, and that's also correct, as long as you have the corresponding parts lined up.